Databases are not new. Having ways to be able to store data, query it, and serve it back to our users has been a key focus of web application development for decades. Relational databases that were developed in the 70s still provide the backbone of our internet, but database development has not stood still. Companies have worked to be able to provide us with new features, faster ways to access our data, new ways to store and represent our data that are more like the real world or more like the realm of knowledge we're trying to model. Hi, I'm Kevin from Buddiebase, and in this video I want to talk about some of the database trends that are going on, some of the companies that are leading the charge, so that you can take advantage of these new developments and use these futuristic databases in your next project. Let's dive in. So first up we have serverless. Now serverless is not a new concept, it's something that has been getting more and more popular, and it doesn't mean no servers. What it means is that someone else is responsible for running, managing and maintaining the servers that your databases are built on top of. That makes it easier to get started because you're not having to set up the infrastructure, you're not having to work through the technical details of getting everything set up. You can just get your data up and running. It's often more cost effective because you're often paying for what you're using rather than what you're not using. And generally, it's a scalable solution. It's easier to get more databases spun up because you ask for it and the serverless database provider gives it to you. There are two companies that are taking those 70s style databases and making them available in a serverless way. First up, we've got PlanetScale. It provides MySQL in a serverless way. We get a great dashboard, we get ways to be able to monitor our traffic and to see how things are going, and we get highly optimized and cached queries. In terms of pricing, there's a generous free tier. As our needs for more reliability and more deployments to other availability areas increase, then we can increase our costs. And we have separate production and development databases just at a click of a button. Postgres is another database which has been around for a long time, and Supabase is making that available in a serverless way. If you use Firebase, Supabase is a great alternative that allows us to manage our data serverlessly. It manages authentication, and we can get set up with edge functions that are acted on our data from the edge. Again, there's a generous free tier for when you're getting started, and pricing increases based on your usage and your need for the availability of the data and keeping your database warm and ready as things go on. The next trend I want to think about is cloud native databases. Now, these run in the cloud, but are built for the cloud from the ground up. That tends to mean they're more resilient, they self-heal better, they may take advantage of distributed processing in ways that other databases don't. Like serverless databases, these can be scaled up as the need arises, and things like backups, updates, and scaling can all be automated. Because these databases have been designed first with the cloud in mind, they take full advantage of those features from the ground up. CockroachDB is one company that was built in this way. They wanted to help us scale, survive, and thrive, which is great. When you create a Cockroach cluster, you get to decide which cloud provider you want to use. You get to determine the region and have multi-regions if you would like, and how many resources you want to be able to allow this cluster to be able to access. As with all the products we've seen so far, there's a free tier and a dedicated tier. There's also a self-hosted option, which allows you to bring this infrastructure internally to your ecosystem, which for some companies can be really important to have that data air gapped from other platforms. So the ability to self-host is really powerful. FaunaDB is another database that is also cloud native, was built from the cloud in mind. It's fast and it's reliable, and it has what they call a TypeScript-inspired developer experience. So the types that you set enforce that schema on the documents that are added. And the API to be able to query the data and get what you want in the way you want it looks like TypeScript. So if you're coming from TypeScript or JavaScript, this will feel really familiar. So as well as being cloud native, Fauna is the first document database that we've looked at. So not only SQL, a NoSQL database. So that means as our data changes shape over time, or if we have unstructured data like logs or feedback from multiple IoT devices or something like that, we can accept that data in whatever form it's in and process it after the fact. So they have a pro plan that you've got free access to when you sign up for 30 days, which is $500 per month after that. Which allows things like logging, unlimited developers, unlimited databases, big throughputs, having global region groups for multiple regions and all the rest of that. And it also has a free plan, mostly designed for people who are learning Fauna and keeps quite heavy limits on what you might need, but you can remove those limits for as little as $25 a month to be able to explore using that database. Next up, branching. If you've used Git before, making branches and merging back to main will feel like a really normal workflow. And now there are databases that allow you to do that in the same way. We can check out new branches, which will take a snapshot of the data and structure at that point in time. We can make changes to that structure and merge back into production once we're happy that the new data structure is something that we want to carry out. One of the companies that introduced us to branching is Neon. Neon is a serverless Postgres database, much like Supabase, like we talked about earlier, but it also provides this branching feature. On the free tier, you can have up to 10 branches. You can have new branches that you create from the dashboard, or you can have them automatically generated based on events like a Git push or a new feature branch or something like that. Neon acts just like a normal Postgres database, so we're able to interact with it in much the same way as we would in any other way, with just this added advantage of branching. In terms of pricing, we again have a really generous free tier, so one project, 10 branches, 3 gigabytes. And then you can start to upgrade, starting at $0 for the upgrade. If you've been on the free plan and update to a pro, building your app and maybe using it with customers, you get some estimates about what costs might look like. So my current sample database would be 3 cents per month at the current use cases. But you can see sort of typical prices up all the way up to scale. So you get some idea of the cost that you might be managing to incur. All the metrics are based on what you use. So if you have customers who are using your service a lot, you're going to be paying more. If you have service that's not being used or just in development, you're not going to be paying anything or not very much at all. In their documentation, they talk about how you can branch with just a single click of an API, either through deploying, development, and then reintegrating. You can also create a preview version of the database for every PR, which can allow for really good isolation of data with large teams who are collaborating across multiple features simultaneously. Next up, multi-model databases. These are databases that are designed to integrate different types of data through a single backend. This means they can accommodate data in different types: relational, non-relational, graph data, allowing developers to make the choice that they need for their use case while not isolating that data from the rest of the application or institution. This gives more versatility. It gives more flexibility to developers. This also allows for better efficiency. There are times when you're developing a feature that would work better in a relational database when the rest of your application is built with a document or NoSQL database, and vice versa. And because the data is being integrated through a single backend, it allows for more consistency, which is amazing. So SurrealDB builds itself as the ultimate multi-model database. It provides a query language which works like traditional SQL but can be applied against graph and databases and time series databases. It has really good query performance and manages to enable machine learning and lots of other cool features that are really powerful and really interesting and exciting. At the moment, they don't offer a hosted experience for their database. Instead, you need to spin up a machine to be able to run this yourself. So it requires some more DevOps knowledge for you and your team, but the efficiency and flexibility may be worth it for you. Couchbase Capella is another database that's built with multi-model in mind. It allows you to consolidate those multiple data technologies into one architecture. So everything's ingested into Couchbase and then it's queryable by their API. Ultimately, Couchbase is a NoSQL document-based database, and so what the data structure tends to be human readable and standard JSON, but also has what they call SQL++, sort of even better than SQL, they reckon. So it's versatile, affordable, and as easy as SQL. So you can see that it looks very much like a SQL query to be able to query the data. Select statements with joins and groups and havings and limits. So if you're coming from a SQL background and you want to dip your toes with NoSQL and you're in between both camps, Couchbase Capella can be a really good middle ground as you decide which way to go, and maybe you decide that this is where you want to end up. So they don't have a free tier, so you can stand up Couchbase in any of the cloud platforms on your own rather than having them manage the infrastructure. You can choose that. You can air gap it for yourself on your own cloud platform as well. Or you can have them manage it. They bill by time rather than usage because the nodes are always up. They always have access to the data and they're processing that data as it goes. So you can decide if that's a more fully managed approach versus you standing up your infrastructure in the cloud is going to be better for you as a team and more cost effective. Next up are graph databases. Graph databases are NoSQL databases where the relationships between the data are seen as important as the data themselves. They're particularly useful when we're thinking about highly connected data, like social networks or supply chains, thinking about recommendation engines or fraud detection. There are kind of three core components. There's the node, which represents the particular entities or things, person, product, that kind of thing. There are the edges, which are how the different nodes are connected. And there are key value pairs called properties that exist on either the nodes or the edges. They're really efficient when we're trying to explore relationships. They're quite flexible. It's easy to add in new relationships and new nodes. They're quite intuitive because it's how the world tends to work and how we think about things in relation to reality and social graphs. And they're quite performant. As the data set grows, they stay quite performant in terms of querying. They don't require joins because those relationships are already embedded in the database already. A really common implementation for graph databases has been Neo4j, but Memgraph presents itself as a more performant, faster implementation of Neo4j. So you can run this on Docker on your local infrastructure, a community edition for completely free. You can scale to billions of nodes and edges and stay really performant. And we're able to use any graph that you might have implemented already with Neo4j, you're able to bring with you into Memgraph. In terms of pricing, the community edition is free. There's an enterprise edition which includes things like auth and role-based access control and full activity auditing. And they have recently released a cloud beta version where it's fully hosted and managed, which involves multi-regions, automated updates, and managed backups, which is pretty cool. In terms of the pricing around that, depending on how big you want your instance to be, if you're running it in the cloud, one instance of 1 gigabyte, you're looking at $25 per month. Another trend in databases are time series databases. Databases where every data point has a timestamp. These time series data are measurements or events that are tracked and aggregated over time. We'd have things like temperature, stock price, CPU usage. So lots of real world things that we want to be collecting this data on. When we're thinking about a database like that, first of all, everything needs to have a timestamp. The database needs to be optimized for high write volume. So because we're expecting to write to this database probably pretty continuously. So getting those writes quickly and efficiently is going to be super important. The database will have really good skills to aggregate the data. So computing sums and averages over time periods that are defined to be able to get answers from the data that's there. Generally, there'll be retention policies. There'll be so much data that you'll think about, well, do you retain it for a month, a year, however long, that it's actually useful rather than wasting storage on data that you're not actually using anymore. They need to be pretty scalable. These databases tend to scale horizontally to handle growing data size. Often these databases are optimized with really good compression. So if you're storing this data, you often take up less space because the records are being compressed really well. And finally, the query languages that go around these databases are often really helpful. So these kind of more specialized query languages that might be additions to SQL or entire query languages separate to themselves are really helpful to be able to answer the questions you might be asking of this kind of data. There are a number of databases that are implementing time series, and InfluxDB is one. It is single purpose. It runs at scale in the cloud, on premises, or at the edge. So you can run this serverlessly. You can run this managed on in your own infrastructure, and it's really helpful to be able to manage that. It's got really fast write, reduction in storage costs, faster queries. So all the things we were hoping for with time series databases, InfluxDB is trying to manage. It does have native SQL, and it's got some other ways to be able to interrogate the data. InfluxDB also comes with really good SDKs for pretty much every language that you can think of. So from JavaScript, Python, Go, C#, and Java, we've got really good implementations and really intuitive ways to be able to understand our data. In terms of pricing, you can start for free. So they give a $250 credit, which you can play with, fully managed, elastic, multi-tenant, and only pay for what you use when you go over those credits. So a really good way to explore and be able to work out if this is the use case that you want to use, the data you want to use. And on all three of the cloud platforms and their marketplaces, it's a single click install to get up and running with this. So if you want to subscribe there, you can manage that. The final trend I want to talk about is embedding AI into databases. Embedding AI brings really powerful data management and data analysis tools inside of our database. As database administrators and developers, we're able to leverage AI and machine learning in place. Leveraging AI models using SQL, using AI to be able to enhance and enrich our data, and be able to apply machine learning and AI algorithms to our data. There are lots of benefits in doing this directly inside of the database. First of all, it's easier to use. It's using the same query language and is not something new for people to have to get their heads around before they can start applying it. It can be more efficient, performant, and secure because we're not moving data from our database to our other system that does the machine learning and the AI. It's happening in situ, which means that we're saving costs in moving that between one place and another, and we're not have any risk of man-in-the-middle attacks or losing the data or it leaking in some way to some malicious third party. Because the type of analysis and anomaly detection that AI and ML allow us to do, being able to do that inside of the database means it can be real-time, live analysis using those algorithms that have been developed to enrich the data, to get new answers based on the data, and to really answer those queries in more specific and useful ways. AI models can help improve the data quality as well by identifying errors and anomalies and inconsistencies within the data as it's being entered. We can have AI algorithms just checking on the way in. So this is quite a competitive space. There are a number of database platforms that are seeking to be AI first, to embed AI into their platforms. MindsDB is one. It integrates with lots of different data sources like Slack or Shopify, Postgres, and lots of others like that. Ingests that real-time data and can apply lots of machine learning and AI, and then can enrich that data again. And that can loop around, so we have super powerful data. You might use this to build your own custom chatbot or large language model. You might build fraud detection or anomaly detection. There are lots of things that you could be building with this to be able to manage it. And on the MindsDB website, they come up with some ideas that you might be able to apply to your application. If you are thinking about building an application using AI, then doing that at the database layer provides some interesting opportunities. In terms of pricing, there's a demo tier where you can just get up and running and have a look at it for free. There's an open source version that you can deploy yourself. There's a sort of a one-click deploy. And then there is a starter tier where you pay 70 cents an hour, and that's pay as you go to be able to explore that. So this fits lots of the trends that we've talked about over the course of this video. We have multi-model, cloud-first infrastructure, and we're adding in these extra AI components to make it really powerful and give us really interesting ways to build interesting and useful tools. At Buddybase, we want to help you turn your data into action. So whether you're using a collection of REST API endpoints or a relational or non-relational database or some kind of spreadsheet or S3 data store or any of the other kinds of databases that we've talked about during this video, we want to help you use that data to build tools for your colleagues to be able to do their jobs quicker. If you want to build an application and don't have a data source set up though, we do have our own data source, which is built on top of CouchDB. It's a super fast and it's a really fast and easy to use database, which you can add columns to like a spreadsheet. It's a database that allows for collaboration for multi-users. It's speedy, but whichever data source you have added into Buddybase, you can build really intuitive and helpful internal tools. These tools are saving companies thousands of hours, and maybe they could do the same for yours. Have a look at our website or some of the other videos to see if Buddybase is the right fit for your next internal tool. Thanks for watching. Bye.